Record to the cloud. All right. Thank you for keeping me in your prayers. I feel so much better now than I felt last week. Would call it like a full recovery, which is a wonderful place to be today. So we're going to be today talking about debugging and error handling. There's a file to download. So go to vbacourse.blogspot.com and then download that product list.xlsm file. Oh, forgot, we're going to start off by doing our little quote. And someone says, hey, are we getting any extra credit for doing these quotes? The answer is no. Just I used to use this for taking attendance. I decided not to take attendance this semester. But people told me they like the quotes, so I'm going to keep doing the quotes at the beginning of class. This is from Thomas Paine. You remember Thomas Paine? He's the author of Common Sense, which by the end of 1776 was the document that had been printed more often than any other document except for one thing. What was it? The Bible, yeah. And then this was printed more. This was like the next most printed thing after the Bible, which is amazing to me. So Thomas Paine's Common Sense. Thomas Paine, by the way, do you know what his occupation was? He was a stays maker. He made women's underwear. That was what his job was. And he wasn't really very good at it, but he was an outstanding writer. He says this, again, kind of in the space of private virtue. When we're planning for posterity, we have to remember that virtue is not hereditary. And that's the whole point, is that, you know, we have this guy who's fantastic. We love him so much, we want to make him a king. Problem is, he's got a son. And son, you know, not so great. Probably because he was a king's son. I mean, it's probably the whole reason that he's not so great in the first place. So yeah, he actually does. He makes the pledge before he knows how popular it's going to be, but he donates all the proceeds from the publishing of Common Sense to the Second Continental Congress to be able to, you know, fight the war with Great Britain. Really interesting. All right. So then here is, let's see, I am recording and we are sharing a screen. Yeah. Okay, so here's the file then that we're going to be working with. This is actually product data that was from some online like outdoor outfitter back in the early 2000s, I think. It was the website was called outlaw.com, is where I kind of got the information from, just took a copy of their database. And then they went out of business not too long ago. But, you know, this is kind of, it's interesting because it's got real, you know, these are real products and so forth. Okay, so today we're going to be talking about kind of two closely related, first I want to make sure any questions administratively. So we have an exam that's running all this week. So you got to get yourself over to the testing center sometime this week. Remember that the exam is not timed, so you've got as much time as you give yourself to do it. There is a, you know, there's an end of the day over there, so you can't like work through the night. So make sure that on the day that you're going, you know what time they close, and give yourself enough time to go over there. How many of you is like, oh boy, this is my first time I've ever been to the testing center here at BYU? Yeah, so I know it's a delightful place. What's that? Where is it? Oh boy, it is. Yeah. If you know where the Mazer building is, like it's the one that's on the southwest corner, kind of overlooking Provo. It's a kind of a really old one. It's not that one, but it's right next to it. So it's right over there in that neighborhood. Oh boy. So no one loves taking a test in the testing center, but let me tell you, the thing the testing center allows us to do is it allows us to take off any time pressure. If I administer an exam here in class, you're going to be limited to how long it takes to do the exam in class. I'm not comfortable just giving you a take-home exam just because I know that people work together on take-home exams, and it's unfortunate, but that's what happens. And so I can feel like I really am getting a major of your own work without having to have a time pressure, and that's the real reason I get it into the testing center. So just go over there. Most folks do the exam the vast majority do it in less than an hour. The fastest ones do it in about 30 minutes. And then some people just love it so much they extend it, make a day of it, bring a lunch and whatever, I don't know. So, but yeah, time to get out there and get the exam. And it looks like while I was gone, they like redid everything. Like all of my settings have been undone. I got to get my font set back at larger here. Hey, why don't we all go ahead and do this together? Let's just make sure we've all done this together. So here I am in the Visual Basic Editor. I'm going to choose Tools. I'm going to choose Options. And I'm going to make sure that Auto Syntax Check is turned on. And then, I'm sorry, no, I'm going to turn off Auto Syntax Check. That's the one that's going to display the little dialog box every time you make a syntax error. We're going to turn that one off. We're going to turn the next one on, Require Variable Declaration. That means when we create a new module, it's going to come up and say Option Explicit. There, we'll talk about that today again. I guess this is pretty relevant to today's discussion. Then I'm going to come to my editor format and get to a font that I'm a little more happy with. Microsoft Sans Serif. Western. 28 points or something, 18 points. Whew, maybe too big. I think we'll be able to see it okay in class, so that'll be great. All right, looks like you've given us a runtime error, a syntax error to begin with already. Okay, any questions then before we get into today's content? In the back, go ahead. Okay, yeah, so the question is, what's the best way to study for the midterm exam? It's this. Come to Learning Suite, into the schedule, and it's probably on today's day in the schedule, yeah. So here's the midterm study guide. So here's what I did. I said, all right, I've gone through all the chapters that we've had assigned reading on, and I went through them and said, okay, what do I really care about in this chapter? And then I said, that's a section. I wrote these down section by section by section. So if it was something I thought, don't spend your time on that, I'm kind of throwing that out at the very beginning. So I went through and said, this is the stuff that I think is important from the textbook and the stuff, and it should be no surprise that it largely overlaps with what we've covered in class. Then when I made the exam, I went through the study guide and they said, okay, I put this into the study guide. How do I write a question to see if the students understand that? And then I would I'll write that question, go to the next one. How do I write a question so the students understand that? I got to one of those and it's like, I don't think I could possibly write a question to see if you understand that. I'm going to skip that one. You don't know which ones those are. I don't remember which ones those are. So, but most of them, there's a question from every segment there on the exam. So that really is the best thing you could do to study, is get together, go over that, and then maybe get with a study buddy and talk through some things. Maybe invent some questions each other to kind of practice with. Other questions? There are 50 questions on the test, but I think the last 9 questions are questions like, prior to taking the exam, how prepared did you feel you were and studied? Did you think the test was fair? There's a few questions like, I felt there were several questions that were trying to trick me into taking the wrong answer. Trying to get a feeling for how you felt about the exam before you get your score that way. So I think there's actually 41 questions where I'm actually asking you to do some VBA stuff. Yep. Do you get points for those questions at the end? The answer is no, there's 0 points. I think you could leave them blank and it wouldn't affect your grade at all. Yeah. Question? It's Scantron, no computer allowed. You will be allowed to take in scratch paper, and I encourage you to take scratch paper into the exam because a good segment of the test is going to be, here's a block of code. What does this put into A1 of the active sheet when it's done executing? And so it might be really helpful to be able to kind of draw into memory, okay, there's a variable here with this name, and this line is going to change that variable. And then down here, you'll say, oh, that one's going to add 2 to that variable, and I should go and change what that is. So you'll definitely need a pencil because it's a Scantron exam, but I encourage you to take some scratch paper in as well so that you can, because I think it'll be helpful for that part of the test to be able to take some notes. Not some notes, but to, just kind of draw things out. Other questions? Yes. Yeah, so it sounds like, you know what, I haven't been to the testing center as a student for decades. And I don't remember, but it sounds like we have some students here saying you're not allowed to take any bags in with you.
You can take a backpack in.
Take a backpack in. So just carry your bag in, put it under your chair. You're not allowed to look into it. Go ahead.
If you have your phone in your bag and it goes off at all, just tap it. So compensate yourself. So turn off your phone or don't bring it in.
Same with your Apple.
Yeah, get your technology into the bag. Don't open the bag, silence it, turn it off, whatever. Did you say they'll confiscate your test? Wow.
Even the phone rings a signal, right? Yeah, there's always like a line of backpacks outside, like people just don't want to deal with that problem. So you just want to like.
Okay, so it sounds like, because I know the folks that are maybe watching this on video or hearing this on Zoom aren't actually hearing what the students are saying here. So, you know, if you're going to take a phone or some kind of smart watch into the testing center, make sure it is off, because if it like goes off, like even if it's in your bag while you're taking the exam, that's a no-no. And I don't know exactly what I don't know exactly how you're going to get communicated by a certain ringtone that comes into here. But anyway, apparently it is. So just make sure all that technology is off. Maybe leave it at home. One student said a lot of folks just leave their backpacks outside of the testing center, like probably indoors, but outside of the actual room where you go for your exam, just because you don't want any risk of having your phone or exam confiscated because somebody called you. Yeah, we didn't have to deal with that when I was a student. They didn't have smartphones when I was a student at the testing center. So challenge. Okay, other questions? You do have to wear an orange jumpsuit. You know, it says Department of Corrections on the back. So yeah, make sure, actually, you do have to follow the dress and grooming standards. They won't give you the test if you've got a beard, unless you've got a beard card and so forth. So got to make sure that you're you know, following the dress and grooming standards. Okay. So yeah, so that's that. What are we doing today? Today, I think, is this even our class? Oh yeah, 11th. So here we go. So today we're talking about error handling and debugging. So let's go ahead and got something here called process products. It looks like it's kind of pretty straightforward stuff we've done before. Declare a row as a variable, a long integer. We're giving it an initial value of 2. We've got some kind of syntax error here we'll play with, but we've got a loop that's starting here. It's going to print off some stuff, so that looks great. And increment row. Okay, so once we get this code running, it looks like it's just going to print off the names of the products. It's going to print off column 6. What's in column 6? 1, 2, 3, 4, 5, 6. So yeah, it looks like it is the name of the product. So it should just print off the column 1, the ID, and then the name of the product. Okay. So kind of generally speaking, in terms of debugging, there are 3 kinds of bugs. There are fundamentally different kinds of bugs, and we got to treat them all differently, like these 3 categories. The first category is the one you see in front of you here. It's called a syntax error. Syntax error is, oh, by the way, do you know why they call bugs bugs? Yeah. Yeah, back in the very early days, whether it was the ENIAC or another computer that was like it, the way that we used to program computers, it seems really strange to us now. There was no language. What you would do is you had a whole series of magnetic relays, and you're making connections from one relay to another, so that as information flowed through, it would trip these electromagnetic switches that would then, you could then read kind of the lights that came out on the end. You could know, what was the output of the problem that you were calculating. And so, but it's a mechanical process where the switch, power goes to this electromagnet. It then pulls down a switch, which joins 2 other wires together to kind of continue on the sequence of what it's doing. And, it had the whole program entered, all the wires connected up the way they think they should be connected up. and it wasn't giving the results that they knew that it should give. It was giving completely strange results. We'll come to find out that a moth had actually gotten into one of the magnetic relays. So even though it got the signal to close the circuit wasn't closing because the moth was there. And so that was literally, it was a bug in the program, and they had to get the bug out of the program. And so, but that's where the term comes from. When you talk about having a bug in your program, you know, it's something that's preventing your program from doing what you think it's supposed to do. Of course, chances of it being caused by an actual insect today is really, really slim, but still kind of where the term comes from. So the simplest ones to track down are called syntax errors. And a syntax error, what you have done is so bad that the interpreter looks at what you've said and says, I have no idea what you're talking about. You've written something here, and I'm looking at it, and I don't have the faintest idea what you want me to do with it. And so fortunately, our Visual Basic editor is able to look at that line, and it can know, even before, long before we try to run the line of code, it can look at that and go, we don't know what you're talking about here. Okay, so where is the error in this line? I mean, it looks pretty good to me. I got the beginning of a loop here. I got some condition over here. That all looks really good. What's the problem? Yeah, until is spelled wrong. So a legal word here is do while or do until. But here I've spelled until incorrectly. UN. I'm going to change that back to TI. And now it goes, oh, okay. Yeah, now I understand that. The interpreter, my code editor is smart enough to kind of look at the syntax and go, yeah, that looks like it's syntactically valid. And so it could say, I can understand all what this is. I think this has a pretty good chance of running when it's time to run. And so it's tempting to think that all of your syntax errors are going to show in red when when you're kind of working in the Visual Basic Editor, and that's not true. For example, what do you think? Is this, if I get rid of the word loop here, is this line syntactically valid? I mean, is this code syntactically valid, or is it, do I have bad syntax? I've got bad syntax, because if I've got to have a loop somewhere. Well, where's the red line? There's no line to make red because the line that needs to be here is just missing. So, it's not true that if there's no red lines, you have no syntax errors. It's just the editor is making it red if it can help you track that down. That's wonderful. So that's the first category of errors, syntax error. And in a syntax error, your only option is you've got to get rid of it. There's no other way around it. The third category of error, we'll talk about the second one, which brings us into error handling. The third category of error is called a logic error. Now, logic errors are just the opposite of syntax errors. Syntax error is so bad, the interpreter looks at it and goes, I can't even begin to fathom what you want me to do here. Logic error, the interpreter looks at it and goes, oh yeah, I totally get what you're asking me to do. And when it comes time to run that code runs just fine. Well, where is the logic error? If it's not in the code, where is the logic error? Logic error is in your head. You told the computer to do something different than you thought you told it to do. These are the ones that are really difficult to track down because the interpreter doesn't give you any help finding it. As far as the interpreter is concerned, there's no error at all. It's doing exactly what you told it to do. And if the interpreter was smarter, it might say, you told me to do something really stupid here. And it might tell you that. But the interpreter is not smart at all. It can't figure out that what you told it to do was kind of crazy. It just knows, oh yeah, I can do that. You want me to do that? I can do that. So logic errors are where we've written the code wrong in such a way that we think we've gotten it right, but it's not producing the correct answers. These are the ones that having various debugging tools are going to help us track down because they're really hard to find. In fact, let's just go ahead and talk about what one of the really benefits of that. One of the strongest tools for debugging these are, and it's right here, option explicit. So unlike most of what we write in VBA, option explicit isn't executable code. It's not like when this code starts running, it says, okay, do whatever option explicit tells it to do. No. Option explicit, and there are several kinds of options that we can do. We'll talk about another one of these options when we start talking about arrays. But an option is what's called a compiler directive. it says to the VBA interpreter, all right, before you start trying to figure out what all this stuff says, I'm going to give you some instructions about how to interpret the stuff that you're going to see. So this is an instruction to tell the interpreter how to behave. And what we're saying here is that if, this is me saying, listen, if I'm going to use a variable, I am requiring myself to explicitly declare it. So, here I've got, dim row as long. And that's right, I'm declaring a variable here. And if I didn't have option explicit done here, and I didn't have this variable declared, if I tried to run this, this runs just fine. In fact, if we look at the results, we can see that it's printed off all these different product names. But with option explicit here, if I try to run this without declaring the variable, it says, hey, hold on a second. You are trying to use a variable here that you haven't declared. And so option explicit requires me to declare my variables. The reason that's so helpful is that one of the most difficult things errors to track down is a misspelled variable name, especially if you've got some kind of long variable names that you're using here. Like suppose here that I actually had row equals RO, instead of ROW, I'll put ROVV. And we'll suppose that in whatever font I'm looking at here, that really does look like a W instead of two V's right next to each other. Is this valid syntax? Yeah, that's valid syntax as long as if I haven't set option explicit. So without the option explicit directive, this looks just fine. In fact, if we look at it, this will create an endless loop. So while this is running, it says, all right, row is going to be 2. We're going to do until, looking at whatever row is blank. This is going to be row 2. It's going to be something there. We'll print something off. We're going to set row equal to a new value. What's it going to be? It's going to be ROVV. What is that? Some variable that my programmer hasn't yet defined. And because option explicit is not on, it goes, oh, you just must mean you just want me to declare a variable. So it'll declare a variable, allocate memory for it. It's going to make it of the data type variant. I'm treating it like a number, and so it's going to pretend that it's 0. And so I'm going to set row equal to 0 plus 1, which is 1, which is why it's printing off the header row here. And that will just keep on going because I'm never, ever incrementing row. And that's what I'm using to get out of this loop. So I've just taken what should be a really easy to track down syntax error and converted it into a logic error by getting rid of option explicit. So option explicit, I really encourage you to say, even though you might think, oh, so it's a pain to have to declare all my variables, declare your variables, and it will really help you in being able to debug your code. Because a misspelled variable name is a tough one to track down. Questions? Okay, let's talk about the third kind of error, a runtime error, and then we'll talk about trapping that, and then we'll talk more about debugging in general. Okay, so in between syntax error, which is so bad the interpreter has no idea what to do, and logic error, which the interpreter says no problem at all, we have this thing called a runtime error. So for runtime error, let's do this. Let's say that I'm products, what are we doing? Debug.print products, that's the sheet here. Why don't we do this? Make a new procedure here. I'm going to call this save value in list. What I'd like to do is I'd like to be able to kind of conveniently create a list of unique values from any column that I've got over here. So I've got several columns with duplicates in it. I'd like to be able to find out, gosh, what are all my different possible, what are these departments? What are my different manufacturers? And from this data, I don't have a list anywhere that's just the unique values. I'd like to be able to generate that pretty easily. So I have a sub procedure save value in list. And let's just do this. Let's let's pass a list name as a string, and let's pass a value. List name and value, VALUE, as a string. Okay, so what I'd like to do is I would like to, I'm going to have a worksheet over here called lists. I'm going to make a new worksheet called lists. I'm going to have my code do that for me. So let's start off just by assuming that the sheet called list is already there. So let me dim s, let me call it, I'll call it the list as a worksheet. And we'll set the list equal to, pardon me, we'll set the list equal to the worksheet called lists. Okay, now, as I look at this code, syntactically, how am I doing? I mean, you guys are probably much better at seeing syntax errors than I am, but do you see any syntax errors here? Well, the interpreter isn't queuing us to any, they're not giving us any red lines, so it looks like it's pretty good. I think the syntax is okay, but what's going to be the problem when I go to run this particular line right here? Yeah, go ahead. Yeah, there is no worksheet called lists. Syntactically, this is great. Here's a variable that's an object variable, particularly of type worksheet. And so it uses the keyword set just as expected. Little equal sign says you're going to try to bind on some object reference to the object variable. That sounds great. Shows up here and says we got the collection of all the worksheets. That's wonderful. If I'm going to refer to an element in my worksheets collection, I'm either going to give it the name, some string representation of a name of a worksheet, or I'm going to give it a number. So syntactically, this looks really great. The problem is that my editor here isn't smart enough to look at that and say, well, wait a minute, there is no worksheet called lists. You know, and imagine how sophisticated it would have to do to be able to know that, because for all it knows, by the time this goes to run, maybe the sheet will be there. It doesn't know what's going to happen before this thing runs. And so it just thinks, hey, this is just fine. So when I run this, oops. Oh, I'm going to have to make a call to this. So let me make another sub procedure. Its purpose is just to call this one for debugging purposes. Sub call save value in list. Okay, so I'm going to, just for testing, I'm going to pass in department and hunting. So I'm going to make a list called department, and I'm going to put a value into that list called hunting. Okay, so now I'll go ahead and run this, and now I get a runtime error. Wait a minute, this is a compiler error. Sub or function not defined. Because it's worksheets. That was a syntax error, incidentally, not a runtime error. There we go. Now we got a runtime error. So the runtime error says subscript out of range. It says, listen, if I hit debug here, it'll tell me this is the line. I made it all the way to here. And when I tried to actually do this, it failed. Because this says, give me the name of one of the worksheets, and that doesn't match one of the worksheets that's in this workbook. And so it said I tried to accomplish this, but I couldn't do it. So that's a runtime error. Syntactically is fine. The interpreter says, okay, I know what I'm going to try to do. But when it actually tries to do it, it fails. And it's typically because, well, I don't know if there's really a typical reason for it. In this particular example, it's because there is no sheet called lists. And so it can't very well bind onto it because it can't actually evaluate. Okay, so for runtime errors, we need to get rid of them like we get rid of syntax errors, but we can't necessarily get rid of all of them. it's really possible that we won't know that the error is going to happen until we try to make it happen. Or it could be that it is so expensive to find out if the error is going to happen to do it, that we would rather just let the error happen and then handle the error. Imagine, I mean, what do I have to do to make sure that that sheet exists before I try to bind onto it? What could I do? How could I make sure the sheet exists before I connect onto it? What's that? I could write an if statement, but what I do in the if statement? What am I looking for in the if statement? Yeah, if there's a worksheet that has it, but how do I, that's the part I have, that's the part I'm learning how to do. How do I say if there's a worksheet that has it? We know enough. Oddly enough, there is no statement that just lets me ask, does this sheet exist? Be nice if there was, there's not. So we know enough to track that down. What would it be? I could write a loop that loops through all of the worksheets in the workbook and checks to see what's the name of this sheet. Does that one equal what I'm looking for? Does this one equal the one I'm looking for? Does this one equal what I'm looking for? So, and the truth is, for a small workbook, I mean, the code to write that is pretty simple. And I might just write I might write a little function that's just called sheet exists. And I pass it the name, it checks through all the worksheets in the specified workbook, and it returns true or false if it finds it there. And then I could know that it's going to exist before I bind onto it, otherwise give a message to the user to some extent. Now, but it may very well be that I've got hundreds of worksheets in this workbook, and it's going to take, will that take a little time to loop through hundreds of those? Probably still less than a second, but it's going to take some time to loop through that. And if this is a process that I have to do over and over and over and over and over again, I mean, it's something I have to access a lot, it may take more time than I want it to be sure the error is not going to happen, especially given the idea that the error is only expected to happen very, very, very seldom. And so it might make more sense to say, listen, just try it. And if it fails, it's going to be so rare that it fails, it'll take a little longer for the code to run when it fails, but that's better than having it take a longer time every single time that it runs to be sure that it doesn't fail. Does that make sense? And so, there's some times where you say, you know what? It's not that it would be too hard to prevent the loop from happening. It's that it's going to be too expensive, or too hard to prevent the error from happening. It's that it's going to be too expensive to be sure that the error doesn't happen. And it will be less expensive for us then just to kind of watch for the error is going to happen and then say, oh, okay, I saw the error happen. It's not the end of the world. We can kind of decide what to do from here. And so that is what's called an error trap. And that's what we're going to do right here. Okay, there's a couple different ways to write an error trap. The book talks about both of them. I'm going to show you the simplest one, the one that I think has the most utility in most of the stuff you do with VBA. So here's what we're going to do. We're going to come here before the line that we suspect is going to cause the error. And I'm going to say on error, resume next. On error, resume next. That says, okay, if there's an error, after this line of code executes, if there's an error, just ignore it and move on. This is a really dangerous line of code just to put in by itself because it converts any runtime error into a logic error. It just says, as far as the interpreter is concerned, no error. You'll never get a runtime error will never show up because you're just saying, hey, if there's an error, forget it and move on. So I mean, if I go ahead and run this now, there'll be no error. I mean, it's not going to do anything, but run it. There's no error because we said, hey, if there's an error, just skip it and move on. Let me go ahead and put a stop in here so we can kind of explore what our options are at this point. And actually, I'm going to comment out the error trap first and run it one more time. Okay, so this tells me I'm getting subscript out of range, runtime error number 9. Okay, so now I'll put my error trap back on and run it. Let's go ahead and move my immediate window up here to the top. Okay, so the neat thing about having set up this error trap is that it actually takes that error message that before just shows up as halt the code, here's an error, and it puts it into an object. There's actually an object called ERR. So I can say ERR.number, and that'll tell me, oh, error number 9 happened. Now, it didn't stop my code from running because I have the on error resume next, but now my code can snoop around in the error object and it can say, ah, the error happened. And then I'll decide what to do if error number 9 happens. What does error number 9 mean? It means subscript out of range, which means you're trying to refer to an object in the collection, and the value you gave me to identify the object in the collection doesn't identify an object. There's kind of a historical reason why we call that a subscript, even though it's probably not the best word for it today, but just realize that's what that particular error means. So if I get any other error, I wasn't expecting it, but if I get runtime error number 9 at this point, I was totally expecting that. That means there's no sheet called lists. Go ahead.
So does that line of code have to be the exact line right before the error happens?
So-
Or is it not gonna-
The question is, does this have to be the line just before where I'm expecting the error to happen? And the answer is no, but I do want to put it pretty close. So because I only want this, I am building this around an error that I'm anticipating. It's a really bad idea to put this at the very top of your procedure because, especially if you've got other lines of code that are in here, well, there may be a runtime error that you weren't anticipating that kind of, comes up through something you never even thought could possibly ever happen. You don't want that to accidentally suppress that error. So you want to build these really tightly, this error trap really tightly around the block of code that you're anticipating to have the error. I just noticed that there's something on chat here. Let's see if I can see what the student's asking here. If there is an error. So I guess that's the answer to a question. Thank you, student, for answering that question. I wasn't paying attention earlier. Okay, so now, but the trick is, because I can read this value, I can decide what to do as a result. So right after the line that is potentially going to be problematic, I'm going to put an if statement. And I'm going to say if error number equals 9, then this is the one I was anticipating. If error number equals 9, I'm going to put a little note here. This means the list sheet does not exist. Okay, so what do I want to do? What should I do in this situation? Any thoughts? I'm just going to make the sheet. That's the problem. It doesn't exist. I'm just going to make it. I'm going to fix the problem. And so let's come here and just say, so now I'm going to set the list equal to worksheets dot add. Now, I do need it to be called lists, and so I'm going to give it that name as well. So the list dot name is going to equal lists. That feels pretty good. Let me come here and let's do this. If error number 9 is that, let's do another one here. If error.number equals 0, then, what do you suppose error number 0 is? A little bit louder? One more time. The end. Error number 0 is not the end. Well, I guess it is, in a sense. It's all the way at one end. So error number 0, I don't know what error number 1 is. Error number 5, I think I know error number 5. I think error number 5 is like an overflow. But error number 0 is no error at all. So when my error object has a number of 0, there's no error. And so I kind of want to think about what are the different possibilities here. Listen, if it's error number 9, you know what? I was expecting that. Let's just go ahead and handle that. If it's error number 0, that's no error at all. So I'm just going to kind of leave this little line in here to say this is anticipated, right? This means we did find it. And sometimes you've got code that you want to say, okay, yeah, I do want to run some code specifically just in this error trap if there was no error, but we're going to want to run all of our code in that case. So I'm going to leave this one with no actual code in it. So what about this? Else, what does it mean if I make it to here? Yeah, it's some other error. So it wasn't error number 0. You know, if there was no error at all, here where it says error number 0, it's going to come into this and branch out, and it'll skip by the else. If it's error number 9, we'll skip by the else. But if we get here, there was some other error, and it's one I wasn't expecting. So whenever I read an error trap, it's a good idea to say, you know what, because you've put yourself into this dangerous situation where an unanticipated error is not going to flag anything, you should do something to say, well, if it's an error that I wasn't expecting, let's still get some protection with it. And so what I'm going to do here is I'm just going to put stop right here inside the code. So that's going to tell me, you know, this is code that, you know, I'm writing for myself. If this is code that I've got to put into production, you know, and someone else is going to have to, you know, actually deal with this error, I probably should do something a little more sophisticated than just taking me into break mode and kind of taking me to this part of the code. But at least while I'm doing this development, this is going to be a good approach here. So now this will be a pretty, I think this should be a pretty good solution. So when I get to this point, now at this point, I know that there is a sheet called lists, and the list is bound onto it. Whew. Do I type worse now that I've had COVID than I did before? I don't know. Okay, I'm going to go ahead and run this code again. Let's see. So I don't have my lists sheet here. Go ahead and run this code. Block if, else. Oh yeah, this should be else if. Thank you very much. Okay, so now we're here. And that time through the code, it actually created a sheet called lists. And I'll go ahead and stop the code, run it again. And we get to that same part of the code, didn't create another sheet because it came through here, it bound onto it just fine. And so it would have flowed through. Let's just go ahead and step through this one so we can see it. So here's one of our debugging tools and we've already talked about it, but we can set a breakpoint here. Then when I run the code, we can just step, and I'll use F8 to step through this one line at a time. F8. So it's not number 9, it is number 0. So we've dropped all the way to the end if, and now we're moving on. So in this case, I like building the trap this way, especially in a setting where I would have lots of worksheets to look through to see if the sheet already exists. So you know what, just try to bind onto it. And if it fails, create it, bind onto it, and then move on. Is the question here?
So how does this work retroactively, right? Because we're creating a list. Well, sorry, I didn't think about it.
Yeah, so the idea here is that when I call this sub procedure, save value in list, I'm going to give it a list name. We haven't actually gotten to the logic of what we're trying to create here. I'm going to give it a name for the list, and then a value in the list. And so the idea is find that, and we'll just kind of put these lists into different columns on the list sheet. So in my first row, let's just go ahead and do it now. Let's just go ahead and kind of get down to what we're going to do. Okay, so now what I want to do, so what did I pass in here? So I'm trying to create a list called department, to be a list of all my departments. I want to find out if that list is already on this sheet. And the way I'm going to tell if this list is already on the sheet is that it's going to be sitting here in row number 1. I'll put the name of the list right here in row number 1. So let me just go ahead and declare a variable here. I'll call it found cell as a range. And we've already done some work with how we find specific cells. Lists dot rows number 1 dot cells dot find. And I'm going to be looking for whichever list was passed in, and that is called list name. So I'm looking for list name, and I want to do XL whole. XLW. XLWHOLE. And let's set found cell equal to that. So truth is, I don't remember all the arguments here. Find is, we're looking in this range over here, trying to find something. What are we trying to find? Whatever value got passed in. In this case, it's the word department. We're trying to find it on the first row, and we are looking for a whole match. We're not caring about whether it's case match or not. We just want to make sure we found the whole word there. So now, if we found that, then we know, oh, then we've got, in fact, let's just do it this way. Set found cell FOUND, thank you. In fact, let's just assume that we're going to find it, and then we can do a little more with error trapping here as well. So just to get us a little more experience writing an error trap. So this is going to tell us what we're interested in is the column number that we find it. So instead of found cell as a range, let's make something called the column as an integer. Oh, and by the way, once we've gotten to here on this error trap, I want to kind of turn off this error trap, because once I say on error resume next, any other error that happens after that is going to get suppressed. So what I'd like to do is I'd like to say, okay, now I've written my little error trap around that. I want to turn off that error trap. I want to essentially say, go back to your VBA, go back to your normal way of handling errors. And so I'm going to do that right here after this if statement. I'm going to say on error go to 0. That is a really strange syntax to say what we're trying to say here. Back in the really, really early days of BASIC, we had to number every line. It was terrible. You'd have to say, this is line number 1. This is line number 2. And you'd write the line numbers in it. And you would use those line numbers to branch different parts of your code. Say, oh, if this is true, then jump over here and just go back up to line 3 and keep executing from there. It was hideous. Well, the very first legal line number was line number 1. And so by saying on error go to 0, you are telling it, you're telling the interpreter to do the impossible. There is no line number 0. And so how it seems like they could have come up with a better way to say this, but on error go to 0 just says turn back on normal error handling. Turn back on normal error handling. All right, go ahead and get rid of the stop. It's there. Okay, now we have potentially given ourselves another possible runtime error here. And what is the possible runtime error? In fact, let me just go ahead and run it and we'll see the error. That's not the error I was expecting. Oh, it's called the list is the name of the sheet. And this is not going to be an object variable. It's just going to be a regular primitive variable. And I'll go ahead and run here. Okay. Says that the object is not set. So we get here. What's the error? It's a runtime error. Syntactically, this looks great. Says that we're going to have some reference to a range, and we're going to ask for the column of that range, but it's giving us an error. Says the object isn't set. What is it? What's the problem? Yeah, go ahead.
Is it giving you back a letter column? Like, you know, they did this integer, so it counts like that?
So the question is it giving us back a letter, but we're trying to receive it as an integer? And the answer is no. Column is going to give back an integer value. So it's not that it's giving back a letter. We're trying to put a string into a letter. Let it play again here and look at the error message. Object variable or block with variable not set. What we're telling it to do is we're telling it to look on row 1 and find whatever list name is. List name is department. So let's go look at the sheet. And it's looking across here. Where is it going to find the word department in this row? Where does it find it? Should I zoom in so you can see a little bit easier? Yeah, there's nothing here. And so our code assumes that that this is going to find it, and then we're asking it to give us back the column, but that's not a range. It does not find a range. And so when we ask for the column of that nothingness, it goes, yeah, there's no object there for me to return that value to. So we could kind of write ourselves around this one so it doesn't have an error, but since we're looking for some practice writing an error trap, let's go ahead and write another error trap here. So I'll come here and say on error, resume next. On error, R-E-S-U-M-E, next. I'll have the line that potentially has the code, or that is going to potentially cause the error. And this is error number 91. So then I'll put my if statement. If error number, let's go ahead and handle 0 first. Error number equals 0. Then we won't do anything. Else if error.number equals 91, else stop. Okay, so this means the list was not found on the sheet. So in this case, we just have to build a list. We've got to set up the list. So should be no problem. So we're going to say the call equals, and then let's just go find the, we want to find the next empty column to be able to write data onto. So we've got our worksheet called the list, and we're talking about cells. Which row do we want? Row number 1. Which column do we want? The very last column. We're used to kind of coming to the bottom of the sheet and coming up. Now we're going to go all the way to one side of the data and come back over. So that will be columns.count. From here, we'll say end Excel to left. And Excel to left. And then we want the column of that +1. All right, let me go ahead and put a breakpoint here. And we'll run it to this point. Shift F8. Well, I guess we had another breakpoint up there. Okay, so it shouldn't have found it. It's not runtime 0. It is runtime number 91. And now we should have gotten the column number that we're after. And so that is column number 2. So now either we will find it up here or we're going to create it here. Now we're ready to give that to give a list, give that list the name that we're trying so we can find it the next time we're after it. So let's go ahead and write that in right here as well. So we're going to look at the list, which row cells, which row are we on? Row number 1. Which column are we looking at? The column. Dot value and equals whatever value we were looking for, which is called list name. Go ahead and take these off. And that should now give us the department here. And our next step will be, now that we know the column, is to search in that column to see if we are finding the actual value we're looking for, in this case, hunting, and do something really similar here. Questions? Because we turned on this error trap here, let's go ahead and turn it off again just when we're done dealing with it. So on error, resume next. I'm sorry, on error, go to 0. Questions? On the first block up here? And then we could use the same approach. Now that we know the column that we're going to be looking for the value in, we can check in that column to see if we've got the value that we're looking for. And if it isn't there, just go ahead and write it in there. If it is, report that it's there. Okay, so that's a couple of times through building what's called an error trap. So this is how we deal with runtime errors. If we can, you might just say, you know what, let's just write the code so that it won't fail. But then the other approach is to say, let's keep an eye on it, know immediately when it does fail, and then have our code behave accordingly. All right, let's go ahead then and talk about what some of our other debugging tools are. Biggest debugging tool that you have is to be in break mode. So, get in there with a breakpoint. Run your code. And then you've got your immediate window, because when you're in break mode, you can look at all your variables. You want to know what the column is? Question mark, the call. And it'll show you the result right there. It's going to be a little tougher to see here, but there's a nice tool here called your locals window. And I'll zoom in so you can see it. So down here, let me see if I can undock it so that we can see the whole thing. Windows ++. Yeah. So this is going to say, here's variables that you've got declared here. So here, it's actually showing, here's the list. Well, anyway, here's the column. Not quite sure why that came up. Go away. But here's the column, and it's showing us that value. So you can have your locals window open, and as you're stepping through your code, going one line at a time, you don't have to pause to go ask what the variable is. It'll just show you the value of the variable. So that's this tool. So the biggest tools you have for debugging, one, this locals window is great. Your immediate window, because you can always probe and see what this is. Or we show you one other way to deal with this, and that's called setting a breakpoint. I'm sorry, setting a conditional breakpoint. So let me come here to the column. And I'm going to right click this and I'm going to say, oh, let's talk about watches first really quickly. I can say add watch. That's going to bring up another window called my watch window. It's kind of like my locals window, except I decide which expressions I want to watch. So I can put individual variables into the watch window, and then they're just like it's just like they're in the locals window. I can kind of watch them change as the code goes line by line. But I can put more complex statements in here if I want to. So it doesn't have to be just a variable. It could be a whole expression, and I can kind of watch how that expression changes. But now that I've got this thing called the watches window open, let me go ahead and come here to the column, and I'm going to say add a watch. Now the kind of watch I'm going to add, instead of just one that I'm looking at, I'm going to add a watch that will, bring this over a bit more, that will take me into break mode when the condition changes, when the value changes. So now anytime the value of the column changes, we're saying, listen, I'm not exactly sure when this is taking on a value that I'm not expecting it, but every time it changes, take me into break mode so I can see the next line it's executing after that. And so this is called the conditional breakpoint, right? A breakpoint, normally you set it on a line either with the word stop, or you put the little dot somewhere and it says, right before I execute this line, take me into break mode. This kind of conditional breakpoint says, I'm not sure exactly when it's going to happen, but whatever line causes this to change, take me into break mode right after that. And so this can be really handy in trying to track down where something's changing when you're not expecting it to change. So now I'll say okay. And I've got a different little symbol up here. So this is the conditional breakpoint. And this says when the column, whenever its value changes, that's when we're going to go into break mode. So let's go ahead and zoom out. I'll stop my code here. I'm going to go ahead and take off all my regular breakpoints. And then I'll run my code. And here we can see that we've come into break mode here because right here is the line that changed the value of the column. So that conditional breakpoint got triggered because somewhere in my code, we changed the value of column. That's what we asked the conditional breakpoint to do. We said, listen, as soon as the value of this changes, take me into break mode. Now, you can see that it actually highlights the line after the one that we're hoping to find, but that's the best we can do. As soon as that line executes, the interpreter goes, oh, wait a minute, that value just changed, I'm supposed to stop. And it stops and shows you the next line that's going to execute. Questions? Go ahead.
Can you remind me how we open the locals?
How do we open the locals? Yep, just go to the view window and say locals. So view locals. Or I think the watches came up when I right-clicked something and said add watch, but it's got the same thing here, view watches window or watch window. Other questions on debugging tools? Okay, let's talk about a little bit more sophisticated stepping into. Now that we know how to create sub-procedures that call other sub-procedures, go ahead and stop this code. We're going to look at a little bit more sophisticated at stepping. So here I've got a sub-procedure that I've created just to be able to test this one where I've got to pass into it a couple of values. So rather than have to try to type it in each time or something, I'm just going to call this sub-procedure that passes in these test values. What is this? OS magnifier. Okay. So let me put a breakpoint here. And when I go to run this with F5, it takes me here into break mode. Now, if I come up here to my debug window, I've got three options for step. I've got step into F8. That's the only one we've used so far. I've got step over Shift F8 and step out Control Shift F8. Okay, so step into says, yeah, just execute this one line at a time. But I actually want to step into this subprocedure. So, I mean, one way to look at this subprocedure is that's one statement. Just to execute that as a statement, but that's not what step into does. Step into says, oh, we're going to go through this one line at a time. So if I hit F8, oops, come down here, hit F8, which is step into, it's going to go through this one line at a time and do what it does. So step into says, so step into is only relevant if you're actually on a line that is a call to another subprocedure or function procedure. So the question is, do you want to just go run that whole thing as if it's one statement, or do you want to go through it one line at a time? And step into takes you through it one line at a time. Step out, Control Shift F8 says, oh, you know what? I'm done watching this work. I get it. You know, get me out of here. So step out does not skip anything. It just finishes running this and takes me back to where I was before I got here. So if I choose Control Shift F8 or on my debug window choose step out, it finishes running that line and then takes me back to where I was before. That's not quite exactly where I expected it to go. It's why did it stop here? It stopped here because I still have this conditional breakpoint set. So let me go ahead and get rid of this. Let's see. How do I delete it? Do I just have to delete it? Delete what? There we go. Okay, so let's try this again. I'm going to run this one. I'm going to step into it with F8, execute a few, and then I'm going to come here and say step out. So now we just finished running all the code down there, and now we're on to the next line here. So the other thing that we can do is instead of F8, I can do Shift F8, which is step over. Now step over, boy, it almost sounds like I'm going to skip that line. I mean, if I was looking at a line there and I would decide to step over it, I would just bypass it. But that's not what it does at all. Instead, it just runs it as if it's the whole thing is one statement. So instead of stepping into it and step through it, it just says, go run the whole thing and take me to the next line. That's my way of saying, listen, I know the problem that I'm trying to track down is not inside this subprocedure. So just run that subprocedure and let me continue on. So these three, step into, step out, and step over, basically allow us to control when we are trying to go into another subprocedure that we've written, or to step out of it, or just run the whole thing as if it's one statement. And I find that most often I'm interested in step over. So that would be Shift F8. So it just runs that whole thing and then takes me back to where we were. Questions? Let's see, any questions coming in on chat? No? All right, those are the main tools that I use in debugging. Being able to step through your code one line at a time is huge. Being able to watch those values either in a watch window or in your locals window, also really, really helpful. Because as we get into more complex stuff, your code's not going to do what you're expecting it to do. And you'll need to kind of be able to see and work through exactly why that is. All right, let's call that good for today, unless there are any other questions. Class dismissed.